Okay, so we did the power series representation of e to the x. Now we're going to do the sine and cosine. So we're going to develop it the same way. The second differential equation that you're going to learn how to solve, okay, y double prime equals negative y with y of 0 equals a, y prime of 0 equals b. Okay, so again, I'm not showing you how to solve it yet, okay, but it shouldn't take you much to say that, you know what, y of x equals a cosine x plus b sine of x. That's going to solve this, okay? All right, so what we're going to do, we're going to go ahead and we're going to develop the series the same way. Again, this is still sort of not really what we do in Calc 2, but it's a good motivation and it gets you working with these things a little bit, okay? And you will definitely see it in DiffEQ. So, okay. So let's say that we develop a power series representation here. Y of x equals the sum, n goes from 0 to infinity, a sub n x to the n. Let's write this out again. A sub 0 plus a1x plus a2x squared, on and on forever. Okay? All right. Let's go ahead and take y prime of this as well. Y prime of x equals, I'll do it here first, n a sub n x to the n minus 1. Okay. If I do this here, okay, the a sub 0, the derivative of that is 0. So we're going to get a sub 1 plus 2 a sub 2x plus 3 a sub 3x squared, so on and so forth. Okay, let's go ahead and do that shift that I like to do. So it's the same shift that we did last time. N goes from 0 to infinity again, and I'm sort of recognizing that, hey, you know, that first term, the a sub 0 term goes away. So I'm going to have n plus 1, a sub n plus 1, x to the n. Okay? Recognizing that, hey, the first term is when n equals 1, but I really want to have x to the n there. Okay? We're going to do this one more time. We're going to take the second derivative. Why? Because we have the second derivative here. Y double prime of x equals, I'm just going to differentiate this here. So I'm going to get n times n plus 1, a sub n plus 1, x to the n minus 1. I'm going to play the same game, all right? I don't like having x to the n minus 1. I want to have that be x to the n. Also, my n equals 0 term is gone again, right? And if I do this from here, I'm going to get 2a sub 2 plus 6a sub 3x, so on and so forth. Okay, so I'm going to write this as the sum. N goes from 0 to infinity. All right, I want my first term, my first non-zero term here is when n equals 1. So I want this to be 1 and the first non-zero term here to be 2. So n plus 1, n plus 2, n equals 1 is the first non-zero term here, right? That's going to be a sub 2. So that means I'm going to have a sub n plus 2 x to the n. Okay? So here is my y double prime. Okay, again, you're not really going to be doing this whole process, but doing this shift is something that I will expect you to know how to do. Okay? All right, so let's go ahead and go to this differential equation. Now, before that, y of 0 equals a. That tells us that a sub 0 is a, right? Same reason as before. If x is 0, all of these are 0. Okay? Y prime of 0 equals b. That tells us that a sub 1 is b. Same reasoning. Okay, so now let's go ahead and do the find the recursion relation, see what happens. So our recursion relation is y double prime, or actually our differential equation is y double prime plus y equals 0. I'm just taking this equation and putting it on one side. Okay, here's my y double prime, here's my y. So sum n goes from 0 to infinity, n plus 1, n plus 2, a sub n plus 2, x to the n, plus y, that's going to be the sum, n goes from 0 to infinity, a sub n, x to the n equals 0. Okay? Again, we're going to get what's called a recursion relation. Okay, this is just, again, matching up the coefficients of x to the n. Okay, so that's going to be n plus 1, n plus 2, a sub n plus 2, plus a sub n equals 0. Okay, so a sub n plus 2 equals negative a sub n over n plus 1, n plus 2. Okay, so far okay? All right. If at some point you take me for DiffyQ in the future, you will see videos similar to this, but I do it a little more aimed towards those students. So it'll be slightly different. Okay, so okay, so let's go ahead and construct the series. Okay, so we have a sub 0 is a sub 1 is b. I'm actually going to put it in 2 lines, 2 columns here, because this series skips 2. Okay, so now a sub 2 is here. Let's think of this. This is, if I think about it like that, I think about what the n is. It makes it easier. So that's going to be negative a over 1 times 2. Okay. The next one is a sub 3. That's n equals 1. That's going to be negative b times 2 times 3. go again. Let's go with a sub 4. A sub 4, that's n equals 2. So that's going to be negative a times 1 times 2, because that's our a sub 2, right? Times 1 over 3 times 4. Let's just see where that's coming from again. N equals 2. This, oh, that should be plus, is our negative a sub 2. Okay? And this is 1 over 3 times 4. Okay? The next one is n equals 3 is a sub 5. So a sub 5 is going to be 1 over 4 times 5 times b over 2 times 3. Okay, I want you to notice something. 1, 2, 3, 4 is shown up here. Let's put a 1, 2, 3, 4, 5 is showing up there. We do just 2 more. Hopefully you'll start to see the pattern. Let's do n equals 4. That's going to be a sub 6. A sub 6 is going to be, let's see, n equals 4. So that's going to be 1 over 5 times 6 times negative a over, I'm going to write this as 4 factorial. Okay. The next one, n equals 5. A sub 7, so that's going to be 1 over 6 times 7, negative b over 5 factorial. I'm just writing this as 5 factorial. Okay? So, we sort of have what our a sub n's are going to be. Make a little more space. Sorry about that. Let me make a lot more space. I think I went off the edge there. There we go. We can zoom in. Okay, so what is our series? So we can say that if it's even, we're going to get. Now, think about this for evens. It's flipping signs. So there's a -1 to the n. Let's just make sure. So when n is 0, that should be -1 to the 0 is 1. So the n equals 0 should be positive. N equals 1 is actually going to be this a sub 2. So -1 to the 1. Okay, so that's good. What's next? 2 factorial, 4 factorial, 6 factorial. So this should be 2n factorial. Okay. And there's, of course, the a on it. That just keeps showing up. Okay. Now let's look at these odd ones. Again, sign switching. Okay, now when I'm doing odds, I'm going to write a sub 2n. I can do +1, -1. I just like +1 for whatever reason. Okay, equals -1. Now, the first one is positive. So I'm going to want for n equals 0, or yeah, for n equals 0, I want it to be positive. So -1 to the n. Okay, So when n equals 0, this is going to give me a sub 1. That should be positive. Good. Now, what is my denominator going to be? Notice 3, 3 factorial. 5, 5 factorial. 7, 7 factorial. Okay, so we end up getting our series solution is like so. A, we're taking out all the evens. Now I'm still going to do this from 0 to infinity, right? Because I'm basically multiplying it by 2. And it's going to be negative 1 to the n over 2n factorial. And then it's going to be x to the 2n. Okay? Plus b sum, n goes from 0 to infinity, negative 1 to the n over 2n plus 1 factorial x to the 2n plus 1. Okay? So this gives us our series solutions for cosine and sine. So cosine of x equals this thing. Sine of x equals this thing. Okay, and you can take and look at the first few terms and you see it actually, you might have seen something like this before. So the first term, okay, let's take n equals 0. When n equals 0, we're going to get negative 1 to the 0 is 1 over 2n factorial. X to the 0 is 1. The next term is going to be minus n equals 1 is going to be 1/2 x squared plus 1 over 4 factorial, just 24, but we write it 4 factorial. Write that 2 factorial. X to the 4th minus 1 over 6 factorial, x to the 6th. So that is your cosine series. Again, one of those things that everyone in Calc 2 should know. Not developed like this, but everyone in Calc 2 should know this. Okay? Or everyone passing Calc 2 should know this. Similarly, sine of x is x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th, like so. Okay. All right. We'll come back with more. I'm going to now talk about Taylor series or the sort of theory of it. But this is sort of, it was a long motivation. All right. See you in the next video.